Bismillahirrahmanirrahim. We're still talking about the characteristics of EIGRP, and we talked about the different payload types that this routing protocol uses, and we talked about the hello packets, and we said that the hello packets are used to discover adjacencies or neighbors, and this is part of learning the neighbors and the topology of the network in order to support partial and bounded updates. The hello packets are sent in unreliable mode, so the reliable transport protocol used as part of the EIGRP uses the unreliable mode to send the hello packets. The hello packets are sent every 5 seconds, and we discussed also the hold time, okay, where if a router did not receive the hello packets within the hold time, then it declares the neighbor as not available. Okay. We'll talk about the second type of the payload that is processed or dealt with by EIGRP, which is the update. Actually, we talked about the update last time as well. So we said that the update is a triggered update which is sent when there is a network change. So we have a change in the network. One network goes down or one network goes up or something like that. Then we send a triggered update, and this update is sent in a reliable fashion. So we have update and we have acknowledgement, and the update, of course, is works in multicast mode, and the acknowledgement works in the unicast mode. Okay. So the update tells the neighboring routers that there is a network change from my perspective. Okay, from this router's perspective, I lost connection with this LAN. Okay, but that doesn't mean that this LAN has become totally disconnected from the network. So I may actually have, another connection to this LAN through other routers. Okay, so just the fact that this link goes down, it doesn't mean that this LAN is totally disconnected from the network. Which means that there is a chance that this router may still have route to this LAN, but through a longer path. Okay, in which case the router will send an update to update all the neighboring routers that I lost the route to this LAN. However, it will try proactively, okay, to learn another route that would get this router all the way to this LAN, if it ever exists. Okay, so for that purpose, we use a different payload type. Okay, so the update is triggered update that's sent to inform the neighbors about a change from my perspective. Okay, but then the router may actually choose to learn another route for this particular LAN, and the way that it learns that is through what we call message. So the query message. So the router, when it loses the connection, or it loses the route to a particular LAN, it may actually try to send query message to the neighbors to tell them, okay, if you have any route to this LAN, please let me know. Okay. So a query is another type of message that's used to proactively learn about the topology and learn about a different route for a network change that may happen. The Similarly, the query is sent as a multicast message, okay, and the query is sent in a reliable mode. Okay, so the query itself is sent in a reliable mode, and the reply is sent in a unicast reliable mode as well. What does that mean? This means that for the query, I use multicast mode to send to multiple routers at the same time, and I expect to receive acknowledgement that they have received the query. This is reliable mode, right? The difference is that for the reply uses unicast mode because the reply will be sent to one router, okay, and it's sent in the in reliable mode as well, which means that when I send this router the reply, I should expect to receive a acknowledgement. So there are two acknowledgements in this case, and the reason for that is that, well, this is the general case. The reason for this is that the query and reply could happen in asynchronous way, which means that the query gets sent now, but the reply may be received later. Okay, may be received after a few seconds. But regardless, when I send you with a query, you should at least acknowledge the fact that you have received that query. So you may send the reply later on when you process and collect the information, because the query might actually trigger another query from this router to other routers in order to, in a recursive fashion. So this reply might be sent now or maybe 2-3 seconds after that. But regardless, when I send you the query, you should send me an acknowledgement that you have received the query. And then when the reply comes back, whether now or after a few seconds, then also this router will send an acknowledgement. And also this router may receive this reply in a separate time instance from this reply. So the two replies are independent, asynchronous. That's why we need to have reliable transmission for both query and reply. Okay? So for the query, I expect to receive an acknowledgement. For the reply, I expect to receive an acknowledgement. Any questions? Okay? The query and replies, these are used by an algorithm which is called diffusion algorithm, which we will discuss in a minute. Again, the purpose of the hello protocol is to discover and establish adjacencies and neighbors, and these are kept in what we call the neighbor router, the neighboring table or the neighbor table. As we discussed last time, EIGRP maintains three types of tables, right? The neighbors table, topology table, right, and the routing table. So the characteristics of the hello packets is that they are sent periodically. So they are not triggered like the case of update, but these are sent periodically. So every 5 seconds we expect to receive hello packets. There is one exception to this. Okay, when you have what they call multi-point, non-broadcast, multi-access networks. And what we mean by this is if you have a link like this, like serial link, so this link we call it non-broadcast, which means that there is no, it's not a broadcast domain. It's actually point-to-point. It's a connection between two routers like this, and if you have links like this, serial point-to-point and point-to-point, we call that multi-point-to-point. So in that case, there's no like shared interface between these routers, and in that case we actually use a different time interval for the hello packet, which is in that case 60 seconds. Okay, so the logic or the intuition about this is that if you have a broadcast domain like this one, this is a shared broadcast network. Okay, in that case you need to send the hello packets on this interface more frequent. Okay, and the reason for that is that you need to update all the routers on this broadcast domain, because all these routers, they share the same interface. So just for you it's one link, but on this link you have multiple connected, potentially connected routers. So you need to send the route update in that case more frequent. But if you have an interface like this, it's a point-to-point and non-broadcast, in that case you can send the hello packets as frequent as every 5 seconds, every 60 seconds, sorry. So for the multi-point, non-broadcast, multi-access networks, we use a less frequent hello packets every 60 seconds. But for domains like this, we use hello packets every 5 seconds. Okay? As we said, we use the whole time to indicate that a neighboring router is still alive. Okay? And if you don't receive the hello packets for a duration which is the whole time, you declare this neighboring router as dead. And by default, this whole time is 3 hello intervals. Why we didn't say here 15 seconds? Because it depends. If you use broadcast domain, then it's 15 seconds, right? If you use non-broadcast multi-access network, like in this case, then it would be what is the duration in that case? 180. 3 minutes. Okay, so if you don't receive hello packet for 3 minutes, then only then you can declare this neighbor router as dead. Okay. As we have discussed before, the EIGRP uses this is for the route update, right? Uses bounded updates and partial updates. By partial update, we said that partial update indicates only the networks that have changed, whether a network that goes down or a new network that gets connected. Only these networks are going to be included in the update. Okay? And bounded update means that we use multicast mode to send this partial update only to the routers that will get impacted or affected by this update. So if you have a network change which affects only a subset of routers, you don't actually send to broadcast, similar to in the case of RIP. Instead, you send using multicast to only the routers that get affected by this change. Okay? And of course, this happened in triggered way. So the updates are triggered and partial and bounded. Partial means, triggered means that it's not periodical. Okay? Only hello packets are periodical, but the updates are not periodical. They are by default trigger based. So only when there is a network change, we send the update. And partial, it includes only the networks that have changed. And bounded, it gets sent to only the neighbors that get affected by the change. Okay? Any questions? Okay, so we have discussed before 4 different mechanisms for resolving routing loops. Okay? Anyone remembers any of them? For resolving routing loops. Any contribution? Huh? What's that? Loop back? Loop back? Huh? Loop back? No, it's not one of the mechanisms that we have discussed. No. Loop back is different. We'll talk about loop back now, but it's a different concept. We discussed the hold down timer, right? So we talked about the hold down timer, and the hold down timer is unlike the periodic updates. We use the hold down timer to trigger that there was a change and inform all the routers or inform the neighboring routers that they should not accept any update for this particular link or network for a duration of time. After this duration of time, if nothing changes, then we declare that this link is permanently down. Okay. We also discussed the split horizon, right, as another technique for mitigating the routing loops. We also discussed the split horizon with poison update as another variation of that. Okay, so these techniques are still used by EIGRP. Okay, so EIGRP still uses these techniques. However, if you remember, most of these techniques, if not all of them, still suffer from the convergence time. Okay, of course, split horizon is a little bit better compared to the hold down timer. For the hold down timer, I have to stay for a whole duration of time before I declare that this link is permanently down. Hence, I reach to the convergence state again. Right? So the diffusing update algorithm tries to mitigate this part, that I need to reach conversions very fast. Okay, so in addition to the hold down timer and split horizon and stuff, it uses that concept of diffusing update algorithm, and for that it actually uses the query and reply messages that we have just discussed to query all the loop free routes to this link from any other router. Okay. Not only that, well, first of all, the word loop free is a very tricky word, because how do I discover that this route is loop free? In that case, I need to learn the topology of the network very good. I need to learn the topology of the network in a good way. And that's why EIGRP uses a topology table. Okay? So this topology table allows EIGRP to keep all the loop-free routes in the routing table. So first, unlike RIP, which does not use any topology table, EIGRP uses topology table to learn the exact topology of the network. By learning the topology of the network, you know that if you go to this link from this side, you will not have any loops. Okay, so you will never go into loops like this. So in order for EIGRP to generate these loop-free routes, it needs to consult or to check the topology table. What EIGRP does, it uses this dual algorithm to send query and receive some replies in order to keep not only one, but it keeps multiple loop-free routes to a specific network. Okay, and these loop-free routes will be used as backup routes in case any network change happens. So the dual algorithm will query all the possible loop-free routes to a specific network, and it keeps that in a cache, and when there is any network change happens, it actually grabs from this cache another loop-free route. And again, for loop-free route, in order to know that this is actually a loop-free, you have to learn the topology. It's not an easy job. So the dual algorithm allows you to keep multiple loop-free routes to a specific network, which allows you to, once there is a network change, you will grab this loop-free route in no time and put it in the routing table, in which case you reach to the conversion state in no time. But this requires that you have to be proactive and learn all these loop-free routes prior to any network change happening. Okay? And that requires some complications and some overhead that you have to do. So, of course, the details about how the dual algorithm works is out of scope of this course. Okay? And it's discussed more in CCMP and some advanced topics. But what we need to do here, what we need to know, is that the dual algorithm allows EIGRP to maintain multiple loop-free routes to a specific network. And the main advantage of the dual algorithm over the other mechanisms that we have studied so far for mitigating the loop-free is the very fast conversions time. The very fast conversions time. Because of the fact that we maintain multiple loop-free routes, if there is any network change, we grab another loop-free route and put it in the routing table in no time, in which case we reach conversions very fast. Okay? Any questions? Another concept, of course, that is naturally used by EIGRP, which is not by default used for the case of rep, is the authentication. And of course, authentication is used to exchange certificates between the routers in order to make sure that all the neighboring routers are really trustworthy. Okay? So when we receive any updates from these routers, we know that these updates are really coming from an identifiable source of information, in which case we take this information, accept it, and then process it and put it in the right table. Whether it's a hello packet, it's topology information, we put it in the topology table, or it affects the routes, in which case we have to update the routing table accordingly. So authentication, of course, is used between all the routers in EIGRP to make sure that these routers, they are really what they say they are. They are really identifiable and authenticated, in which case the routing information will be accepted. Okay, so EIGRP, as we said, it learns the topology of the network. And if you remember, we have discussed this network before. And this is a little bit tricky part. The message that we need to get from this slide is that this is the loopback that was mentioned a few minutes ago. This interface here uses what we call loopback feature. Okay, so the loopback feature sets this interface as a loopback interface. And remember, the loopback interface is totally different from localhost and all the localhost uses 127. Whatever. Here we talk about loopback interface, which is used to simulate or to facilitate the connection between a physical router and a virtual router which does not exist. So this router does not physically exist. Okay? But we try to simulate the fact that this router exists in order to add other subnets. There is a subnet here which is 10.1.1 .whatever /30. So this subnet actually does not exist. But by setting up the loopback interface, we create a virtual connection to a virtual router to add a subnet and a virtual router to allow the routing to go to these networks. Okay? The main reason for this is to add other subnets which do not currently exist, and we will discuss that in more details when we talk about OSPF. Because OSPF uses this feature inherently, and it uses this feature frequently. Okay? But the concept here is that the loopback interface allows the connection or facilitates the connection between a physical router and a virtual router that does not exist in the topology. So based on that, we create this virtual subnet and we create the virtual router and we allow the hello packets. So in that case, router 2 will send the hello packets to the virtual router, and the hello packets will come back with a reply. Okay? In which case, there will be a neighbor in the neighboring table, which is this router, although this router does not physically exist. So the normal operation of EIGRP will be running in a normal way to facilitate the fact that this ISP router will be, in fact, a neighbor in the neighboring table of router 2, as if it's physical, although it's not physical. So that's the main function of the loopback interface. Okay? Another thing here is the automatic summarization. We talked about the fact that, remember we talked about the fact that RIP is a classful routing protocol, right? In which case, RIP does not send the subnet mask as part of the route updates. صح? But when we discussed EIGRP, we said that EIGRP in general is a classless routing protocol. In which case, it sends the subnet mask as part of the route update. However, the default mode, and focus here, the default mode of EIGRP uses automatic summarization at classful boundaries. So that's a little bit confusing. So the default mode for EIGRP, when you set auto-summarization for EIGRP, although it actually, in general, it's a classless routing protocol, in which case you use subnets as part of the route update. However, when it comes to auto-summarization, it summarizes the subnets based on the classful boundaries. This triggers the disadvantage of auto-summarization, which we have discussed in RIP, which is, can anyone remember? We should speed up, or we should maybe possibly announce the next quiz, maybe next lecture, so that we motivate people to go through the material. So if you remember, we talked about the major disadvantage of auto-summarization, which is it does not support there's no interaction whatsoever. So it does not support discontiguous networks. Remember, we said that if you have a network that belongs to a classful or a major network on this side, and subnets that belong to the same major network here, and there is some network here which belongs to different class, or which belongs to a different major network. In which case, this router will get information about two different subnets which belong to the same major network at this router. And what this router does is that it will use load balancing by mistake, okay, to route information to those summarized subnets. And this will lead to inconsistent information in the routing table. And that was a major disadvantage for automatic summarization at classful boundaries. Okay? So this problem, although EIGRP is a classless routing protocol, but it still suffers from the lack of support of discontiguous network, because of the fact that if you set auto-summarization for EIGRP, by default, it summarizes the subnets at the classful boundaries. What does that mean? If you have a network which is, let's say, like 172.192.168, but this is class C, لا forget about this. خليها مثلا 172.30 مثلا .1.0. This is a class B. Okay? And another network which is 172.30. Let's say 2.0. Oh, sorry. Tamam? So those are two networks. Each one of them is class B, right? So you can summarize these networks in different ways. If you want to summarize these networks at the classful boundaries, then you will summarize them as 172.30. Let's say this is 3. Yeah. So .30.0.0/16. Okay. So in that case, you will summarize those two networks at the classful boundaries. which means that because of the fact that this is class B, this means that you have 2 for network address and 2 for host address, so you have to summarize it this way. You have no other choice. If you have the flexibility to summarize these networks at classless boundaries, then you are not really confined, you are not restricted to use /16. You can use any part which is common between those networks. So let's see. Those 2 networks, one here is 1 and 0, 0, 0, 0, 0, 0, 0, right? And 3 is 1, 1, 0, 0, 0, 0, 0, 0. Okay? If you are not restricted with the classful boundaries, then you can use /17, /18, /19, /20, /21, /22, because all these parts are common. /23 does not work. Okay? So this is the summarization. If we were to use classful, we have no other choice. We use the class of this network. If it's class B, then it's /16. That's it. So the summarization will be based on /16. However, if we have the flexibility to use classless, then we can use /17, /18, whatever. Okay? So if you use the classless summarization, this gives you more flexibility. But unfortunately, EIGRP does not support the summarization using classless addresses, although it actually communicates the subnet mask as part of the route update. So remember this information accurately. So the only way for you to avoid discontiguous networks for the case of EIGRP is that you have to cancel auto-summarization. You have to physically and explicitly cancel auto-summarization. That's the only way you can support discontiguous networks. You can deal with discontiguous. However, the default mode for EIGRP uses auto-summarization, and auto-summarization uses classful boundaries, in which case this contiguous network problem still exists. So the main difference between EIGRP and RIP is the fact that EIGRP communicates the subnet mask. However, it does not actually support auto-summarization at non-classful boundaries, which is a drawback. And we will see OSPF. OSPF does support classless summarization. It does support classless summarization, in which case this particular example can be summarized in one of these prefixes, which means that you can use 172.30.0/17 or /18 or /19. So in that case, you have more flexibility. But the auto-summarization for EIGRP by default uses classful boundaries. So that's why I'm saying it's getting a little bit tricky, and you need to really know the difference between the different routing protocols. You need to be able to articulate that. So between REP and EIGRP, we said that in general EIGRP is a classless routing protocol. What is the definition of classless routing protocol? Is the fact that it simply communicates subnet masks as part of the route updates. So this declares EIGRP in general classless routing protocol. However, when it comes to auto-summarization, there's no support for non-classful boundaries. So auto-summarization by default works at the classful boundaries. So when we discuss OSPF mitigates or tries to resolve that by supporting summarization at different boundaries, not restricted to the classful boundaries. Any question here? Any question? I hope there is no question because everyone gives up. So you have the recording, so you can play it back and forth, and you can get these differences. So that's the auto summarization. We have the concept of autonomous system as well, which we have discussed before. So the autonomous system, there is a big difference between autonomous system and process ID. And that's another a little bit confusing part, is that there is the autonomous system as a concept, and there is the autonomous system field as part of the EIGRP header. So those two notions, they mean different things. So the autonomous system as a concept talks about group of networks that are governed or controlled by single authority. For example, an internet service provider has group of networks. There is the network of مثلا Uridu. It has a network at QU, it has a network at QP, it has a network at whatever. So those group of networks are grouped all together in what we call a autonomous system. So that's an example of an autonomous system, and this is an example of another autonomous system. Okay, so we'll stop here and we'll talk about this next time.